Hey everybody, somebody give me a 5 for 5 and we'll roll right on through. Rolling right on through. That's all we got to do. If you know what I'm saying. Hope everybody's doing good. Thank you, Kathy, Mr. Dragon, Ashley. Thanks for being here, guys. Appreciate you. Yeah, hey Butterfly, good to see you, everybody. Somebody give me a 5 for 5, we'll go ahead and get on there. Get on in there. Yeah, I seen you said no sound. That's just on the entry screen of my live stream. I need to add some music to that. Sorry. I had to change all that stuff up when they copyrighted some of the music I was listening to, using. So, hey Linda, what's up? All right, guys. Yeah, I'll get all the stupid stuff out of the way at the beginning here real quick. I now have super chats activated. Please like, share, subscribe. Normal YouTube crap. I don't even like saying it, but it's there. I'm saying it. So yeah, you guys can super chat if you want. You don't have to. I'm just saying it's an option. People bug me until I got that all hooked up and ready to go. And it's a job, guys. It really truly is. So it does take a lot of time. But I did my channel for 5 years and wasn't monetized. So I think anybody that puts time into a channel deserves at least something like that, And it's only if people want to help. It's not even, the content's not changing, nothing like that. And I will be starting up memberships. So please share it out. But we do have some stuff going on, guys. Sharing's the best thing you guys can do for me. Sharing, liking, subscribing, and watching. Just saying. It's just what it is. Like Adam over on Marthugal, there's no way he could survive, the channel could survive unless everybody helped. And fortunately, they do a really good job over there, and that's what happens. So, they're independent just like me. I mean, I'm not, but anyway. So yeah, guys, hey Ripper. And I'm going to try not to address the chat till I get done, because I know that I do that really bad. So any of my mods, if there's any questions that come through here, please just tag me so I can see it if there's a question. Other than that, I trust my mods. You guys just be adults is all I'm asking. You can have different opinions. Just don't be insulting and don't attack other channels. That absolutely is not tolerated. That will be out of here in 2 seconds, and then you'll get a warning. Then after that, you'll get timed out. Then after that, you just get banned. And I trust my mods. Very seldom. I think I've only overturned one ban ever. Because it was an accident. The person that banned them didn't even mean to do it. So, but I trust my mods. So, anyway, guys. Okay, so yeah, we got this radiation storm, and yeah. Remember yesterday when I got off, I told you guys this thing was creeping up, didn't I? I said it looked to me like if it was going to keep doing that, it could definitely get into S2 range. And that's exactly what happened. Okay, it got up into S2. We haven't seen very many radiation storms this year, or even this sun cycle. They're going to continue to increase because activity on the sun, we're getting close to solar maximum, if we're not already there. We could be in solar maximum right now and not really even truly know it yet. But with that being said, I will say this, that, we just got to pay attention, right? And I will say this too. I truly think that we dodged a little bit of a bullet on this one. And I say that because this thing was moving fast. It blasted off there. If it had did this 2 days, 3 days before, I promise you we would be having a different conversation. Because the CME would have been coming directly at us. But it's not, fortunately. So, with that being said, I will take you guys over here. Now, I want to compare two models here for you guys, okay? And I'm going to show you the difference. Now, this is the NASA model, okay? The spiral model, top down on the left, side cut here in the middle, and then you got our orbital line stretched out in a straight line, okay? So when all three of these match up that it's hitting us, you got to kind of think, hey, it's hitting us, right? You got to really pay attention to that. So with that being said, this is a different CME. This happened just a few minutes ago, actually. It's going completely away from us, okay? That's not really even going to affect us, I wouldn't think. It doesn't look like any of the magnetic lines are able to reach, far enough over to kind of get to us. So, I don't think that one's going to affect us, but the one yesterday that I showed you guys in the live stream, and I don't have the recording right here with me, so I can't really access it. I do hope you guys go back and watch that previous live stream, because I do go in depth on that CME that fired off with this big flare activity in the radiation storm. All three of them happened. Okay. But we are it doesn't look like we're going to take it right on the nose, but it does look, I'm not sure if I want to call it a glancing blow. It's more like a side blow, kind of off center a little bit, but it is on the edge of the CME wake. Okay. But this is NASA's model, and we're not really going to be able to compare like I really wanted to, because I don't have the other model there. But NOAA, this is typically what people use for the official forecast. Okay, so what are we looking at here? Well, this is the same model, right? We got density on the top, and then we got speed on the bottom, or velocity. They measure these things here with the density here, and then you got radial velocity. They measure that in kilometers per second. So roughly, I think it's every 400 kilometers per second is 1,000,000 miles per hour, I believe. Yeah, that's what it is. It's rough. That's a rough rule of thumb type of estimate. Okay, but that that is what it is. So let me do this. Bam! See that? So this is NOAA's forecast. Now both CMEs are there, and I know it's kind of hard to see, but they are there. So when that happens, and there's one behind another one, and I've talked about this at length, we will see a buildup of density in between those two. It's a snowplow effect. Okay, the one in the front's moving a little bit slower, so the one in the back is catching up, and it just pushes all those particles, and they get sandwiched in between those two CMEs. They oftentimes will call that a cannibal CME, but it doesn't truly combine into one. They're still separate. They always will be. And it's because of magnetics. Okay? It would take such a power to really smash them particles together to get them to do that. Because naturally they're going to want to kind of repel each other. Negative and positive polarities. So even though they're coming like that, so basically what I'm saying is you get the first hit, then you're going to get a second hit, and you're going to get a third. But in our case, I don't think we're going to really see much from that first one. And we may not even see a whole lot from that in-between density I'm talking about. Okay? I think we're probably going to catch at least a little bit of this CME from the second one. Okay? The second CME that happened with this event. So as we're looking at this model will show us 2 days behind us and 5 days out in advance. I don't trust it 5 days out in advance. Not many people do. I don't think hardly anybody does, really. Because it's just so hard to forecast out something like this that's so far away, moving at breakneck speeds, and so many directional things to take into consideration. We don't have the satellites like Stereo A, and it isn't out on the side anymore. It used to hang out. Well, right here's Earth, right? Stereo A used to be over here. It gave us a pretty good backside view. Well, Stereo A is now hanging around our planet because it's outlived its life cycle. And they're getting ready, I think they're going to send it back out. But they may be doing software updates or something like that. They may not. They may not even send it back out. I don't know. But it was a great satellite. It gave us another perspective. So we could tell better direction with that. I often would use Stereo A to see if things are really coming right at us. And it's hard to say whether it is or whether it's not, unless you have a couple different perspectives. Now, we do have other satellites, guys, okay? But for what I'm doing here is just kind of like a rough perspective estimate. It's what I call, again, guys, nowcasting, all right? So, again, guys, this is NOAA. And as you can see, we're S2 radiation storm. Now, I told you guys yesterday that means something, but it doesn't mean a whole, a big bunch of bad, right? I'm trying to find the scales. Where did I put them scales at? There they are. Okay. This is the storm scales that they use. And S2, passengers and crew in high-flying aircraft at high latitudes may be exposed to elevated radiation risks. What does that mean? Hey, man, girl. So what that means is pilots, cabin crew, anybody flying that takes a flight path close to the poles or in higher latitudes, which South or North Pole. You know, if you're flying down there, stuff comes in easier on our poles because we're essentially a bar magnet, guys. So we got positive on north or south, and when we have pole flips, it switches and all this other stuff, right? So with that being said, let's see here, I got a question there. Does this cause physical ailments like back pain and stomach pain? It most certainly can. Menacing. It's a great question. I would, I might need to do a full show on that one of these days, probably very shortly. But there's so much research on it. It's not hard to find, and it is legitimate research. And it really affects people's hearts, their mentality, all of that. It really can. It can affect you in a big, hard way, and you don't even know it's happening unless you know what you're looking for. But I also caution people on this. Don't automatically say, hey, I feel bad because we had a CME. Please don't ever do that. You're doing yourself a disservice when you do that. You need to consider health issues first by addressing it with your doctor before you go pointing to the sun. Okay, if it's really bad, serious stuff. Don't be like that, okay? And I know that might sound a little abrasive, but please talk to your doctors and stuff if you're feeling bad. Don't get yourself in some medical issues when you don't have to. Now, I'm not saying that you can't go to your doctor and say, hey, we've got these CMEs and all this other stuff happening, and you explain to them, and guess what? The doctors are now being taught this because it does affect us. So understand that. So your doctor most likely is not going to think you're crazy. They're just going to say, hey, that's, yeah, okay. So he might even suggest that to you. Hey, well, we got this, we got some CMEs hitting, or geomagnetism's up, whatever they would say to you. But heart doctors especially, they really pay attention to this stuff. But anyway, satellite operations. Infrequent single event upsets possible. Okay? Basically what that's saying is, every great once in a while, it might affect a satellite. In an S2. Okay? Other systems, small effects on high frequency propagation through the polar regions and navigation at polar cap locations possibly affected. That's a whole bunch of word salad, right? You guys know I hate word salad. What that means is that you're talking about radio communications. Ham radio operators, GPS, all of it kind of gets thrown in together a little bit when we're talking about this. It just makes communications harder in those areas. If you guys know anything else at all about ham radio operators, they really pay close attention to space weather because it affects it really, really frequently. But anyway, as you get closer to the poles, it affects it more. That's kind of what this is saying. But to the pilot thing I was just saying, they don't want their pilots flying in this very many hours a year. They limit it. So if they're flying during these storms, they can tell their pilot, no, you're not getting on the plane today because of this. Take this other route and go further south, right? Or north. So that's what they do. And they also caution people that are pregnant. Guys, listen, in a stronger radiation storm, when you go up there in those planes in high latitudes, it can be like you're taking an X-ray. That's what it is. It's X-rays. That's what a flare is anyway. A radiation storm, and that's an increase in protons, but it's still radiation. And they do not like to do X-rays on pregnant people. They don't. They hate doing that. So just keep that in mind. That's why this matters. Okay? So there's your scales. I'm not going to go any more because it just frequently gets worse as it goes up. It's like a thunderstorm warning. Now we're going to be talking about a geomagnetic storm probably too. Looking at both those models I was just showing you guys how it's going to hit, I don't think we're going to see anything bigger than a G2 on the upper end of things right now. My opinion was different yesterday, okay? And I'm not afraid to say that. Again, it was my opinion. But as I started seeing more and more data come in, I don't think we're going to get much more in the G2, if we even get there. And I could be wrong again. So when it happens, you can bet your butt I'll be out here telling you what's going on. But I'll let you guys draw your own conclusions by what you guys know and what you guys see and all of that. Hey, Hilly, what's up? Stephanie's in the house. Okay, so let's this is the 29th, and obviously this is the day that this big one happened right there. But notice all the other ones. Okay? This disrupted pretty much the whole sun. It caused things like, it's like a chain reaction. You can almost see it like flash all the way through the whole atmosphere and the surface of the sun. You can see the particles just disrupting everything. So what I'm saying is we could see we're already seeing an uptick in eruptions. That's what you're seeing here. Again, this is SOHO. This satellite sits out in front of the Earth, a million miles closer to the sun than what we are, and it's always looking at the sun. This is a physical black disk. Well, it's black here on this image. I'm not sure exactly what color it actually is, but it's a physical disk in front of this camera. And they put it there to block the majority of the sun's light because we wouldn't see anything at all because it would just be way overexposed. You know anything about photography? You know, or even digital imaging, stuff like that, the same thing applies here. It's got to be able to see it. So anyway, this white circle here is representing the surface of the sun. So as we sit here and we blow this off like this is doing right now, you see how this goes from kind of like little speckles to like a flood right there of sparkly lights. That's the particles hitting the imager, okay? And that's from the protons. That's your radiation storm. Now, when we get really, really big ones, this whole thing will be a complete whiteout. The one back in 2017, I believe, did it. There's been a few others that I know of that did this. I think SOHO was out there in 2003 also. I can't remember SOHO. I'm not sure exactly how old SOHO is. But anyway, I remember seeing some chronograph images and it just being completely washed out like snow. It just is. So, anyway. So, let's go over here and I'm going to show you guys this one more time. Let's go to that. Yeah, that's what I want. We're going to check out the let's see here. Which one gave us the best look? Well, let's do the 94 angstrom. Okay? And that's just a section, a part of the light spectrum that we can't see with our eyes. They measure it. It falls in the spectrum, and 094 is part of that spectrum. We see very little of the light spectrum. Okay? So they put a filter on this thing, and it picks up just the 94. Everything else is eliminated. Okay? So, and then they assign it a color. So what they're trying to do, they're trying to isolate specific gases so we get a good visual of this. So that's what this is doing. Now, as you can tell, it even looked like lightning right there going across the surface, guys. This sunspot is not slowing down either. This thing has become very, very active. We had one down here last week that was really active. Let me, let's see if I can't. There we go. We'll just zoom in like that. Okay, so watch this thing right here. And it's really impressive. So there was the first one, and then boom, there's that one. Then you see the connection lines. You can see the magnetic connection lines there, guys. That's what those big long loops are. Okay? And you can see it just, the long duration part of it. Actually, what I'm going to do is, let's do this real quick. Well, I'll have to, give me 1 second, guys. Sorry. I'm just going to pause it. Then I'll zoom back in for you. All right, so I'm going to be able to control it with the arrows now. Well, I thought I was going to be able to. Let's, I'll do it like this then. There we go. Now I'll be able to. Okay. Well, maybe not. This is, maybe if I click here, does that make any difference? Yeah, there it goes. Well, nope. Anyway, you can kind of see that right there. I'll go slow here. And see it lift off. Look at that. Ain't that pretty cool? And then that's just a bunch of X-ray getting flooded out. And then watch the CME. That right there is the eclipse, okay? The Earth passed between the satellite and the sun. So you see how that's standing up now? It's just cool. And you can see what I mean by, you know, these little lightning bolt looking things. And it's just nothing more than charged particles and X-ray, you know, on these magnetic connection lines. Okay, so there it went again. We'll run it through again here. Okay, see, there's the first one. That one really wasn't all that small either. But that happened and it instigated all this. Okay, so watch. Okay, so you can see it starting to lift off. See that? And it already exploded out. It busted in the middle. And then, here comes the main part of the eruption. So, that's what you had. Now, let's go look at the 131 real quick. And the reason I'm going to show you the 131 is because it did that little flutter thing. And I want to show you guys that again. Because I found it really, really interesting. It was completely interesting to me. I mean, hopefully you guys kind of share that. But let's zoom back in. Actually, guys, I'm going to stay right there with the zoom. Okay, so here we go. Watch this flutter. See that? Watch it right here. And I'm going to slow it down. See that flutter? This is cool to me. I think it's cool. And it's just those connection lines just kind of bouncing around. And it's just, you know, the particles traveling on those lines. So that's what's happening there. But yeah. So, let's go check out seeds. Okay, this is Soho. There it is again. There's your eruption again. Now, this is the Australian model. I showed you guys this already, right? This is our magnetopause. This is our magnetic field, basically. You got the bow shock there. Now, geomagnetism. This is showing us the same thing, but in a different visual. Okay. So this is magnetic pressure. I'll show you guys this one. I'm not going to spend a whole lot of time on this right now. But it looks to be like we're starting to see a little bit of uptick in geomagnetism. And what that means is we got plasma hitting. Okay? Does it mean a whole lot right now? No, it doesn't. It doesn't mean a whole heck of a lot right this second. And the reason why is because it's not hitting all that. You know, we don't have the CME hitting right now. So, if I go on through here, and this is the magnetism. Now, that's the density. And that's the speed up here. Okay? It's just showing us different things. So, all this is going to show you is the actual speed of the particles. Down here, this isn't going to show you speed. This is going to show you the density of those particles. And this is showing you the pressure that it's causing. Okay? So, this is really what matters to most people right here. You see how we kind of took a hit right there? And did you notice that the pressure kind of got relieved? Let me tell you why. It's a flushing effect. When we take hits, especially if it's not a dense hit, if it's a high speed hit, it will actually grab those particles and it'll flush it out the back. So that's why that pressure released off of us like that. Okay? It's pretty clear to see that. So we see that often. All right? Now, let's do this. Okay, so this is the data. I'm not going to spend a whole lot of time showing you guys this either. This is kind of boring. This is the BZ. We look for -6. We're not -6 right now, so I'm not going to waste your time showing you much of this, other than to say this. You see this right here? This is what I call popcorn. That means that when this thing enters a data point, it's a literal dot. Okay? So when they start lining up right next to each other, what's that mean? Well, it kind of looks like it's a straight line, right? So that means conditions are staying very, very stable in the same area. Well, when you start seeing the popcorn, that means it's jumping around some, or a lot. So that means that, we got some space weather currently happening. And that's kind of what we got, some low-level space weather stuff happening right now. We do have some coronal holes that I'm going to show you real quick that are pretty interesting. Let's go here to the 211. We had like 3 of them. That's kind of what's interesting about it. Let me back that off. Okay, so here's a coronal hole here, coronal hole here, coronal hole here. So what's that mean? Well, the surface of the sun is actually colder than the atmosphere. So it shows up darker. So when you see what we call a coronal hole, the corona of the sun has a hole in it, the atmosphere of the sun, it opens up and it exposes the surface. And what that does is it allows the plasma just to flow out. And depending on, the polarity of things, and it travels to Earth on a magnetic connection line. It's not like erupting. It's traveling through magnetics. When we see CMEs and flares, that's eruptive behavior. Okay? Coronal holes, the atmosphere just kind of peels back some, and it exposes all that plasma and charged particles that are on the surface of the sun, and it gets drawn out by magnetism. They move. Just like electricity in your walls. An electron jumps from one to the other. An electron has a negative polarity. So when it can spare, when you have an atom that can spare an electron, it'll jump. That's how your electricity flows. That's just how that works. Magnetism's pretty similar to that. So, and when we're looking at this, notice here on the end of this, we see another little eruption. You see that right there? You know what that's telling me? We actually have another eruption getting ready to happen, but it doesn't look like it's going to come our direction. So let me just take you guys, I'll show it to you what I'm talking about. It's right on the end. See that right there? Watch. See that erupting out? That just happened. Probably happened while I was sitting here talking to you guys. This is the first time I'm seeing it. That's plasma. Now it's not going, it doesn't look like it's going towards us. Okay? And one thing I will say too, that's darker in color, which means it's colder. So I don't know where it could be from, I don't know where that's coming from. It's just not matching the rest of it. Okay? So, again, this is the 211 angstrom, and that's just a part of the light spectrum again. They assigned it purple. I mean, I said this before, they could make this thing baby poop green if they want to. It doesn't matter what color this thing is, because you'll go to another website, and they'll be showing you the same data, but this thing will be a different color. I think the 211 is like blue on one of them. I can't remember which one, but yeah. So anyway, let me let's do this real quick. Hey Flamin', what's up, brother? Aaliyah's in the house. What's happening, guys? Guys, give me a roll call in there. I'm gonna see where everybody's from. Anyway, this is spaceweather.com. And again, guys, they're talking about the same thing. Okay? Obviously, this is the space weather news currently. This is what's happening. This is Dr. Tony Phillips' website, and he does an awesome job over here. But you can see he's basically saying the same thing I am. I think. I haven't really read the article itself, but please go check him out. This was an M6.8 flare. Now check this out. There's the radiation storm. You see how it kind of really differentiates, I mean, it was a pretty good little shot of protons, pretty quick like. So, with that being said, I'm going to take you guys back here for 1 second because I do look for this forecast to change a little bit. I think this is going to, see where this is saying 4? That's representing the KP. Okay, that's the unit of measurement they use here. And when you get a KP of 5, that's a G1 storm. Geomagnetic level 1 storm. Okay? So they're saying midnight tomorrow, UTC time. And if you're on the East Coast, you got to take into consideration there's 4-hour difference. Okay? So you got to subtract 4 hours, I guess. Yeah, I think so. I think that's how it works. Subtract or add. I'm thinking backwards here. Anyway, there's a 4-hour difference. So if it's midnight there, it's 8 o'clock here. Okay? So, yeah, you got to add 4 hours, I guess. Yeah. Okay, anyway, I don't know why I can't. My brain's just not working right with that tonight. Anyway, everything we talk about space weather, they use UTC time. It's universal time. And they do that so that, globally scientists can communicate the right way and things don't get all jacked up. So, anyway, you got 4 there. And I do think that that's probably what they're saying is when this CME is going to be impacting us. Okay? So they don't really have us in a geomagnetic storm. That's the official forecast. Okay? So we could probably confirm that by looking at this model. That was on what, 31st? Is that what that was? Was that 30th? Okay. So roughly about, if you look at the time, the date here, if I take this forward to here. So yeah, that's kind of what they're saying. You see how close the CME is here? That's what they're saying. They're thinking it's going to be here about midnight tomorrow. And they don't think it's going to hit us right on the head. I don't either. Okay? But I'm not so sure that it's going to miss us this far. So, and even if it does, sometimes that wake, because it's just like Earth's going through water. Like a boat going through water. Okay? We're always going through solar wind. Space weather. So it goes around our magnetic field like a wake does around a boat. And it fans out like that. That's why your visual looks like this. Okay? That's why that is. Now, we are taking some space weather here. I can tell you that 100% now by looking at this. So let me, I'm going to start these models up real quick and let you guys look at them. Because I'm just going to grab that. You're going to see waves come in. Here on the end. See that? That wave coming in there. And then here's your density. Look at that. That's just a constant barrage of density there. Close to the end of the day. Now remember, the darker colors are higher dense material. Now, you guys can't see the bow shock here, can you? Like you can up here. Why is that? The bow shock's not down because people will tell you that it is. It's not. Okay? All it means is that the density on one side of the bow shock is the same as it is on the other side of the bow shock. Because this is just showing us density right now. And you'll see it change color here in a minute. You'll see the bow shock just like miraculously visually appear, right? Watch. It's going to happen right about here and about right there. Now what? Oh, hey man, that thing reset on me. Look at this. Okay, you see that? See how it reappeared right there? It didn't go away. It was always there. It's just now the density is different on one side than it is the other. So, I say that every time I talk about this because it's irritating when somebody says that the bow shock is down when it's, yeah. In order for the bow shock to be down, you know what that means? We wouldn't be having this conversation, guys, because one of two things would have to happen. We would either have no solar wind, which would mean the sun isn't there anymore, or our magnetic field is gone. Because the bow shock is literally, by definition, the first point of contact of solar wind hitting our magnetic field. That's the bow shock. So, yeah, I'll just leave it at that. Anyway. Hey, John in the spirit, good to see you, bud. Okay, So, all right, guys. But that's pretty much going to wrap it up for me tonight, guys. You guys got any questions, fire them in there to me. Hopefully I stayed more on point tonight, guys. I've really wanted to kind of hone that in a little bit. I'm going to probably, again, guys, I know people have been asking me about the memberships and all that. If you guys got any ideas, please throw them in there. If you guys want me to do something during the membership stuff, I'll try to get that. Hopefully you guys can support me on that. I'm really looking forward to doing some stuff with you guys on there, and just trying to, take care of my family too, and that's just what I'm trying to do. I tried my best not to have to monetize for 5 years. And now I'm in a position where I'm going to be. So that's just where I'm at. But please don't feel like you have to. So I just want ideas on the membership stuff. Okay? It'd be great if I could. And I've had a lot of emails too after I mentioned my hip. My hip is all jacked up, guys. So, yeah, I'm fine. So don't think anything like that. Back at you. Hey, Ripper. Baka. What's happening? Okay. Hey, Cheryl, what's up? Well, Hope's in there. Brian, Reflection, Tom, Reds, KD, Phase of the Moon, Miss V's in the hizzy. Idaho, what's up, Keith? Seeking Truth, what's up? All right, guys. If you guys don't have no questions, I'm going to go ahead. You're welcome, Keith. Appreciate you, bud. Hope you're doing well, man. All right, guys. I am going to pop off here. You guys have a great night. Anything happens drastically, I'll come back on at least for a short one. If not, you guys will probably see me tomorrow. Hey, Aaliyah. Love you, sister. What's happening? All right, guys. Love you guys. See you guys when something happens, or I'll give you guys an update tomorrow. God bless. Yahusha saves, and yeah, you can drink this Kool-Aid.